Hello, welcome back to Blender Sushi LIVENODING. In this episode, I want to share with you how I created this kind of cloudy text. So this is basically based on the text, of course, and ideally you can just create this using particles. But in this case, I'm simply using geometry nodes. And if we take a look how I created this, so from the text I converted into mesh, and we have this alpha object, and we have a bunch of nodes, and we also have this volumetric material. If I render this out, currently it's not really reading the volume material because I'm using Blender 3.0. We need to actually render this out using 2.93 just in case. So if I turn this into, currently this is like using points to volume, and there's of course like a point cloud that's being animated somewhere here at using time. If we are using volume to mesh, you can see this is, if this is a mesh object in Blender 3.0, we can actually render this out using this volumetric material. Okay, so that's first thing to understand. So what's going on? I just want to show you some interesting thing with the geometry nodes and how you can, if you want to create like a volumetric cloud, you can use points to volume, volume to mesh, and you get this, and you can render this out using volume, or you can actually render the actual volume. And this is different than rendering just the mesh. Okay, so it might be confusing at first, but I'll show you the result of the render. Let me use Davinci Resolve anyway, so maybe you can learn a little bit about this app. This is actually free. It's not open source, but it's free to use and pretty fast to bring in clips. Of course, you can also use Blender. So let's see. So by default, if you open Davinci Resolve, it's gonna be on this panel. Cut. Don't use that cut. Instead, you go to media, and you want to bring in the render. Right. So I think I have a render here. I have two different render. Here's the first one. So this is the render of the cloud with the volume material. This one with the changing and animated sphere. And the other one this one with the mesh actually not changing, just the cloud, the actual volume cloud is actually moving. Maybe this one is more realistic than the other one. With the other one, the balls, okay, the sphere balls is actually moving like this. With the other one, it's not moving. Maybe this is more like a real cloud. Okay, but they are both using the volumetric material. So yeah, let me show you. If we start fresh with just Suzanne, subdivide Suzanne, shade smooth, and we're gonna switch to shader editor, give it a material. We know that we have surface, volume, displacement. We can actually create a cloud shaders just using the shaders without having to displace the objects. There's a lot of ways to do this. You can also use particles, but if you use principled volume, plug this into the volume and unplug the surface, so we don't have any surface shader contributions. It doesn't work with Eevee. You need to switch to cycles. Now it's rendering as volume. You can increase the density, so it's a volume object, right? And if you use something like noise texture, for example, and put this into the density, you can kind of see the noise a little bit. You might need to use math and make it maybe less than, and then play with the threshold here, so you can kind of see, starting to see the cloud. If you switch to 4D, you can animate this 3D cloud, and you can see the cloud moving around. Maybe it's better to also have sun, and we might want to multiply the density, so we can see this is the cloud based on principal volume, and we can animate it. So it's pretty fast, almost like real time. Maybe switch to GPU. So let's save this basic volume. You can see Blender can simply convert 3D mesh into volume. So you could have a text object, give a subdivision, give like the bevel, and let's use the volume material. So we already have like a kind of like a cloud object. We can scale the noise, and this is kind of like, it's pretty convincing despite the, maybe if we displace the mesh a little bit using geometry nodes or using displacement modifier, we can get a cloud that's more or less convincing. Maybe plug this into the color, so we have like a noise affecting the color of our object. Yeah, this is one way to do it. It's so you have cloud and you have 3D mesh, you have the clouds. If you animate this, the cloud will be swimming over the volume. With our geometry nodes creation here, we actually have something extra that you can add. So like I said, ideally this should be like a particle simulations, but let's take a look. So I'm using point distribution on top of text object that's already converted into mesh. Okay, so we need to convert it into mesh so geometry nodes can understand it. So we are scattering points on top of the surface of the mesh, and then here we can control the radius of our points, and then here I bring in time actually here. So I'm using attribute fill, and let's take a look here with a spreadsheet. I think we should be able to see the instance. So before we plug this into, because if we start using point to volume, volume to mesh, or point instancing, things will change, and we don't have the points attributes that we can read anymore. But originally everything is just point cloud. Okay, point cloud, just points with data. In this case we have this times that's changing, we have radius that's changing using time, and we also have time offset. So that's a lot of things going on here. Maybe some attributes can be deleted before we pass it into point instance or points to volume. So points distribute, attribute randomize, so just randomize the point radius and then use the fill. So we have time attributes, and then I offset this time using this time offset value. You might also notice that this is actually looping. Yeah, that's interesting. And so continue on, we have offset the time, and we bring back the time data, and then I use the sine wave function. As a result, I pass it back into time, so the time is becoming a value between -1 and 1, and then I multiply this time sine wave with 0.1, so the value becomes smaller, and then I added a bit of value, and then I just mix them with the original point radius, and then I multiply it again here with just to so that the points to volume and volume to mesh is not too large. So these are the results. So it's just a point clouds on top of surface, and yep, turning it back into mesh. But like I said, you might want to render this out as just point cloud like this, or you can actually use volume to mesh. With Blender 3.0, currently still work in progress, so you might need to use this volume to mesh in order to render this properly. Let me save this. If I switch to Blender 2.93, this is the official Blender 2.93 and should be the most stable. It doesn't have like some feature from Blender 3.0, but still the most stable. You will see here, this is after volume to mesh. So we have this bubbly cloud. It might feel more solid, yeah. I can screenshot this. We can also have direct points to volume. This one less solid, and this is actually using just the cloud volume. Maybe this is maybe something that you want to use, but try both and see which one you prefer. This one up here is just to, this is just for preview. So I'm using icosphere just to instance a bunch of icosphere on the points. So in reality, you can use something like this, like ease on the viewport. You use a switch node. Oh, we don't have switch node here. But ideally, you can just switch between these two with Blender 3.0 and then render the one you see in the viewport is different from the one that you're gonna have in the render. So this is more useful with the latest version of Blender. Well, anyway, so let's take a look at the shader here. I'm using noise, of course, the less than and multiply, the same thing. I can multiply this with a smaller value, so it's probably more transparent, less density. Of course, I have time that I multiply and plug this into the W, so you can see how bubbly this looks like. Maybe this is what you want. And the cloud is changing over time. Let's save this again. I save a lot because saving is cheap and you don't lose anything. So Musgrave height. You can try using Musgrave instead of noise texture, or maybe plug the Musgrave into the distortion just for some additional details. Let's scale this 20 times. Yeah, actually not too bad. It's more cartoony, but sometimes the cloud makes this kind of shape anyway, like real cloud. But if you see something like this, you better run away because it's a hailstorm. It's a sign of hailstorm. So this is a softer looking cloud, and I might actually turn on denoising on the viewport. So if we use denoising, you can see it looks like a plastic at first, but it's gonna calculate more details over time. It's pretty cool. Or just don't use that. Maybe the Musgrave plug into distortion is too strong. Let's try using just the value of distortion. Yeah, I was expecting something that's a little bit softer, and you can actually see the cloud less bubbly. Maybe I need to play around with this value. So if it renders properly, we get something like this. This one is with the static mesh and just the cloud shader doing its thing underneath. Sometimes you can still see the edge of the text, but it's not too bad. Actually, you can maybe just use displacement. This one with the mesh actually moving around. So this is more cartoony. This one is a little bit more realistic. I might actually have another file with a proper setup. It might be this one. Yeah, maybe I should give you just all the blend files. Version 13, and this is the cloud with the noise texture. Okay, and yeah, I can still change the value, of course. If you look at the cloud and the sky in the winter, you get like a purple and pinkish color. Something it's really beautiful, and you have the gradient. Of course, you can do the same thing here. Where's my sky? Okay, the sky is there. Just I'm looking at the bottom. Maybe because this is geometry nodes, I should be able to select it. Let's take a look. Oops, okay, it's too bright now. I have this extra sunlight that I'm just gonna delete. I might increase the air, dust, and ozone. So this is maybe like the cloud in the desert. Maybe in reality you will not see this kind of cloud at the desert. Change the sun elevation. Let's go to afternoon. Changing the altitude. So we are up high at the mountain, and now we can see the cloud. Looks different with a better sky background. This cloud should be just white color. We have other option here, emission color and black body. Cloud with emission is probably more like a fire, so I'm not gonna use that. And black body also maybe related to fire and explosion and smoke. Cloud is more like just the smoke. So yeah, maybe what happened if I increase the density? Points to volume density. Yeah, this is actually looking pretty cool. Save. And again, this is using point to volume, the actual volume. You might want to also use volume to mesh, and the result's gonna be different. This one is more cartoony. This one is more realistic. Just give an extra sunlight. Increase the strength to 100. Try giving different colors so you can see how it reacts. I want to get some kind of like a wintry look. Is the sun upside down or something? Yeah. Now it's from above. So cloud volumetric always have like a, you have the sunlight or the light directions, and you have this shadow underneath. So it makes it looking like a volume, like a what do you call it? Soft fluffy cloud. I'm using this sheet. You can also try Hosek and Wilk. I think you have more easier control with Hosek and Wilkie. I think you can get an easier gradient using this different sky. So it's simpler, but it's easier to get a nicer looking gradient. I want to have like a purple pink sky. Oh, it's so hard to get that color. But anyway, that's pretty much cloud. So like I said, ideally we also have like a proper particle simulations on top of everything else. So particle simulations, and then we have geometry nodes, and then the volumetric shader. I think the shader itself is already pretty convincing, so maybe that's all you need. You don't need to animate with geometry nodes, or maybe a little bit of particles can help. So cloudy text. Alright, so hopefully you find this useful. Thanks again for tuning in, and I'll see you next time. Thank you. Bye.